In this problem, we have a ball that we're going to shoot up at a 40-degree angle and give it an initial velocity of 22 meters per second. And we need to figure out what is the maximum height, the hang time, and the range of this ball right here. So, like I said, we're going to give it this initial velocity, and give it at a 40-degree angle. So essentially the ball is going to go up like this, and then it's going to fall down. So let's translate again English into physics. What do all these things mean? So maximum height is essentially asking what is our delta y. Okay. Our hang time is basically asking time in general. Hang time just means what is the total time of this object in motion. And the range means delta x. So when you see the word range, that's basically asking you what is the delta x. So like every kinematics problem, we're gonna, if we don't know where to begin, we can see that this is an object going in 2 dimensions, which means it's going in the x and y. So we're always gonna write out our 6 things in x and our 6 things in y that we're looking for. So we have acceleration, v initial comma x, we have v final comma x, we have x initial, x final, and time. And on the y side, we're going to look for the same things. A in the y direction, v initial, comma, y, v final, comma, y, y initial, y final, and time. All right. So what information do we know? Right? This is our strategy. We're going to plug in what we know. So all we know really is this v initial is 22 meters per second. And notice it is a 2-dimensional vector, right? It is going not entirely in x or entirely in y, but somewhere in between. So what was my rule when you have a situation like this? Whenever you have something given to you in 2 dimensions, always break it down into its x component and its y component, right? Because if we're trying to figure out all these variables in x and y, we need to break anything that's not in x and y into x and y, because this is what's most important for us. So let's break it down. So this is the x component, and this would be, whoops, that looks slanted. Let's take it straight up. This would be the y component. So this would be v initial comma x, and this would be v initial comma y. So how do we relate all of these together? We can say that the cosine of 40 degrees, so the cosine of this angle is adjacent, which is v initial comma x, over the hypotenuse, which is 22 meters per second. So you have 22 cosine 40 equals v initial comma x. And then by virtue, v initial y is just going to be 22 sine of 40. So let's plug both of those in. And remember, anytime you generate a number in physics, always check does the sign make sense. So does it make sense that we got positive numbers? Well, let's see. So we got a positive x, v initial x, and v initial x is going to the right. So it makes sense it's positive. And this is going up, so it makes sense it's also positive. So we are doing great. So let's add this in. We know 22 cosine 40, and this equals 22 sine of 40. Okay, what about the other variables? So is there any acceleration happening in the x direction? And unless they tell you there's acceleration in the x, you assume it's 0, right? Because for there to be causing something to accelerate in the x, maybe some fuel would have to come out. It would have to be like a rocket where fuel is coming out and that causes it to accelerate. There's no fuel. Obviously, this is just a ball that we're throwing up in the air. In the y direction, though, you have gravity always causing objects to accelerate at a rate of 9.8 meters per second squared. And since gravity always pushes down, we give it a negative. So even though the v initial is pointing upwards, right, it's positive, your acceleration is going down like that. Cool. What about v final in the x direction? Well, let's use our trick, right? If we are starting with an initial velocity in the x of 22 cosine 40, and we have 0 change, right? Acceleration means what is the change in velocity. So if you're starting at something and you don't change it at all, then you are left with the exact same thing, 22 cosine 40. All right, can we do that in the y direction? We start with 22 sine 40. We are changing it, negative 9.8 meters per second every second, so we really don't know what we end up with. So this trick only works if your acceleration is 0. All right, our x initial is 0 because you're just starting at this 0 position. Your x final we need to figure out, and the time it takes we don't know. Y initial is 0, y final is also unknown, right? We don't know. Well, let's see actually. We know the y final is actually 0, right? Because it's going to go up and then it's going to come back down and land on the ground. So at this position, your y final equals 0. This is true. However, what are we trying to figure out? We're trying to figure out, part A says the maximum height, right? So we want to actually figure out what is the y final at the peak. Because if we can figure out the y final at the peak, we will get our maximum height. So when I'm saying, remember in kinematics, you don't have to look at the objects. You can divide the parts you're looking at, right? So you don't have to look at the entire motion. We can just look at it halfway. So we can say describe the motion from the beginning to the halfway point, which is what we're going to do here. So to the halfway point, we don't know what y final is. And then the time, again, is unknown. Okay? So what should we figure out? First, we need to figure out the delta y. So we can go straight to the y column, and we can use a kinematics equation to do that. So let me just make some room here. And all right, let's erase this. And there we go. Okay, cool. So this said 40. Oh, let me change the color. All right, and this is sine 40. Okay, so what equation can we use? We can use, how do we figure out displacement? There's only two equations that have displacement. Delta y equals vit plus 1/2 at squared, but we don't have time. So remember, anytime you're not given time, your go-to equation should be v final, comma y, because we want everything y. So v final, comma y, minus v initial, comma y squared equals 2a delta y. Okay? Because there's no time involved in this equation. So if you ever need to figure out a variable and you're not given time, this is your go-to. Unless you need to figure out time itself, then you'd use something else. So what is v final in the y? And actually, we don't know, I wrote that we don't know v final in the y direction, right? But that is true, right? So if we're looking at this point down here, we don't know what the final velocity is in the y direction. However, so this is a question mark, but I actually misspoke. Do we know the final velocity in the y direction at this halfway point? And the answer is, even though they don't tell it to you, we do, right? In the last video, I taught you that whenever you reach the peak of your orbit, you actually receive a final velocity of 0. Because remember, if you ever throw something up in the air, it's going to slowly slow down, and for a very small fraction of a second, it's actually going to have a 0 velocity. That's how it's going to fall back down. If it didn't do that, it would always continue to rise up. So actually, we do know our v final in the y direction is 0 at this halfway point. Okay, so just think about it intuitively. Whenever you're throwing an object up, it's gonna rise, and then for a split second, it's gonna have a 0 velocity in the y direction, and then it's gonna fall down like that, and it's gonna pick up its velocity again. So this is 0 minus 22 sine 40 equals 2 times negative 9.8. Delta y is just y final minus 0, so y final. And if you plug this into your calculator, you will get that y final is 0.72, whoops, 0.72 meters. Okay, so that is your maximum height. All right, what about your hang time? Well, hang time just means tell me the total time it takes. So this information, right? Remember, we're doing kinematics, we don't have to describe the entire motion. We can just describe, like what we're doing right now, we're describing from beginning to the halfway point when we reach our peak. So this is what we're doing. Maybe I should write that here, to the peak. This is all the information, the x and y that we wrote is from beginning to peak. So if we solve for time right now, given this information, we'll only get the halfway time, right? Because once we solve t equals whatever, that's going to give us the halfway point. So if we want the total time, we can just double it. You could also just rewrite your x and y for the entire distance, but I think this is easier since we already have done most of the work. So let's just solve for time. So we can say v final y equals v initial y plus a y t. Why am I using the y side? You can use the x side if you want, right? Because time is on both sides. But there's not a lot that we know on the x side. There's some question marks, and then we have a lot of things equal to 0, so those will naturally cancel out. On the y side, we have a good amount of information. So that's why I chose to stick to this side. So you have 0 equals 22 sine 40 plus negative 9.8 t. And if you solve this, you will get t equals, give me 1 second, 1.445. So that's your halfway time, which means your total hang time is that, and then you want to double this. So you would get your hang time is actually 2.89 seconds. Because if you double this, you'll get 2.89. All right. And last but not least is delta x. So how do we get delta x? We can say go to the x side, right? It's pretty straightforward at this. When you need something from the x, go to the x side. So delta x is equal to Vix t plus 1/2 ax t squared. This equals 20, so delta x, x final minus 0, so that's just x final, equals v initial, so that's 22 cosine 40, times your time. So what is your time? Let's see. We want to use, we can use this time here, and that would give you the halfway distance. So, or we could just use the total hang time and then get the full distance. So let's just use the total hang time. So that's 2.89 plus, you know acceleration in the x is 0, so that's just all of this. So if you solve for that, you will get that your x final is 48.7 meters. All right, and that gives you your range, 48.7 meters.